Alright, welcome guys. Welcome to the Math 995 CBE time review. I'm Allie. I'm one of the tutors at the tutoring center. I hope that you come and visit us often.
Yeah, and then I'm Addie. I'm a station leader for 995.
Yep, and this is being recorded audio, not your faces, so no video. So we're good on that, but we're gonna not have you guys share your names, and we're gonna try to not say your names, but we won't say your names because of privacy laws and everything. We're gonna post this on YouTube, so.
I'm gonna just call me Batman today.
Batman, perfect. Yeah, but we'll go ahead and get started. Okay, so CBE 5 covers lessons 27 through 32. So we'll go over square roots and solving equations, the quadratic formula, solving linear inequalities, solving linear inequalities with an absolute value, functions, and two variable equations and graphs. Okay. And we're going to get started with extracting square roots. Okay, so when we're doing this, we want to take the square root of both sides of an equation in order to solve the problem. And don't forget plus or minus, because anytime we take a square root, it means that we could get a positive or a negative, right? Feel good about that? Okay, we're going to go ahead and start working through this first problem here. Give you guys a second to look at it. Okay, what's the first step that we've started with here? Not to interrupt you guys while you're solving.
Square root both sides.
Square root both sides. Okay, beautiful. Are we talking like we have our 4x minus 3 squared? Oh, freak.
I think this is the most temperamental one I've ever seen.
Are we back? I'll take really small one. Is that better? Okay. All right. Okay, we're back. Plus 64. Okay, and we said take the square root of both sides. So square root here, square root here. Okay, what do we get when we do that? What'd you end up with?
So you have 4x minus 3 equals plus or minus 8, right?
Yeah. Beautiful. Yep, and there's where that plus and minus shows up with the square root of 64. Okay. So we have plus or minus. What are we going to do with that? Because that's really two different solutions, right?
Then you can add the 3. Or just start with like plus 8 and add the 3.
Okay, beautiful. Yeah, I'm going to go ahead and split these into two equations here. We're going to do one with positive 8.
Sorry.
You're good. I got where you were going with that. Negative 8. Okay, and we're starting with our positive 8 over here. So we're adding 3 to both sides. Beautiful. 11. Take us home with this one.
Oh, and then just add the 3 over again,
Yeah.
on the other one, and then just divide both of them by 4.
By 4. Beautiful. Okay, so our solutions here are x equals 11 over 4 and negative 5 over 4.
And is that how it would be written in the answer box? Would there be parentheses or just?
It'll probably either have it as x equals or it'll have it as a solution set like this.
Okay.
But I'm guessing that you'll just have to answer enter in the numbers.
Okay.
With a comma separating them.
Okay, perfect.
Okay, we can double check ourselves here. Negative 5 over 4 and 11 fourths. Beautiful. Any questions about that problem or these topics? Okay, awesome. Go ahead on.
Okay, so now we're going to talk about the quadratic formula. And we use the quadratic formula to solve for x in a quadratic equation. And so this is the quadratic formula. Remember, it's when a is the coefficient of x squared, b is coefficient of x, and then c is our constant. So we'll go ahead and do this one. What do we need to do first before we can use the quadratic formula?
Put the 3 on the other side.
Yep, our equation needs to be equal to 3, so we'll need to subtract the 3x squared, subtract 3x, subtract 1 equals 0. Perfect. Okay, so when we set up our quadratic formula, how is it gonna look?
So it'll be x equals positive 3x, which is positive 3,
Positive 3.
plus or minus the square root of negative 3 squared or minus 4 times 3 times negative 1.
Perfect.
All over 2 times 3.
Perfect.
I've been working on that.
And that's because this is our A, this is our B, and this is our C, right? Okay, so now we can just simplify what's inside, right? So when we simplify, what are we going to end up with?
I ended up with 3 plus or minus square root 3 over 6.
3 plus or minus square root 3 over 6. Okay, let's see. So we have negative 3 squared is 9, right? So I'm going to just do the part in the square root.
Mm-hmm.
We have 9 minus 4 times 3 is 12. But then, or I guess negative 4 times 3 is negative 12 times negative 1
It's 12.
is 12. So we're going to do plus 12. 9 plus 12 is going to be
Oh, just kidding.
21, right? So,
I just got my signs confused.
ooh, that erased all. That's okay. Yeah, we'll just have to remember if we have a negative and a negative, it's going to become positive, right? So square root 21, and then do you think this can simplify anymore?
Yes.
Yeah.
Yes. How can we check?
Check.
Yeah, how would we simplify it if it were to simplify?
Like you would put a 6 on the bottom of both of them, right?
Okay, yep.
And then 3 over 6 is equivalent to 1 over 2, right?
Mm-hmm.
So it would be, you know what? And this is where I get confused. So
Is this where we pull something out of the square root?
Yes, if there's the factors, right? So we'll have to factor 21. If we factor that, what are the factors of 21?
7 and 3.
3 and 7. And then that's the prime factorization, right?
Mm-hmm.
And so because we don't have 2 of a number, we can't pull anything out,
Oh, that's right.
right? So if it was a different number, say it was 8, and we factored it and we had 2 and 4, and then 4 and 2 and 2, then we have 2 2s and it's a square root, so we could pull out something, right?
Yeah.
Mm-hmm.
But this one we can't. But that is what we would do if you could. So let's check our answer. Oh, they left it unsimplified. But yeah, should be correct.
So we could make one of them into 1/2, but the other one has to stay as square root 21 over 6.
Mm-hmm. Yep. Because we don't have anything on the root 26 that can simplify with 6. Right? If we had 2 root 21 over 6, then we could simplify that to root 21 over 3, right?
Yeah.
Yeah. Perfect. Okay. Now let's do this one. How would we start to solve this?
Foil.
Mm-hmm.
Well, that's how I would do it. I don't know.
Perfect. And what do you get when you FOIL?
X squared plus 3x minus 2x minus 6 equals negative 3. And then I
Perfect.
would add the 3 over.
Yep. I'm going to combine like terms as well. So plus x 3.
Minus 9.
All right.
Oh, minus 3.
And now what do we need to use?
Either factor or use the formula, right?
Mm-hmm.
Okay.
Yep. And since this one isn't going to factor, because the factors of 3 aren't going to give us a 1. So we're going to need to use the quadratic formula. So we're going to do negative b plus or minus square root b squared minus 4ac all over 2a, right? So what is it going to be?
Negative 1 plus or minus 1 squared, or square root 1 squared, minus 4 times 1 times negative 3,
Perfect.
all over 2 times 1, so just 2.
Perfect. All right, so then we'll simplify. Have 1 minus, it's going to be negative 12, so 1 plus 12. 2. And can we simplify anymore?
No.
Nope, we can't. Because 13 is prime, right?
Yep.
And then when you write your solutions, we can write it as negative 1 plus root 13 over 2. Oops, equals that. And then negative 1 minus root 13 over 2.
So how would
Yeah.
it look like if we could simplify?
If we could simplify, we can do it how we did before, where we had the 2 fractions. We had like 1/2 minus root 21 over 6 or something like that.
Mm-hmm.
And then we'd have 1/2 plus root 21 over 6 would be our 2 solutions.
Oh, okay.
It looked like on the other one, though, they just left it unsimplified. So I'm assuming if they left it that way in the CBE review, you could probably put it in that way on the exam.
Okay.
Yeah, from what I've seen with the CBEs is once you get to that point, it's like simplified enough. If we just have it like everything solved out inside of the square root, you can split it into like the 2 different fractions and like reduce it more, but it will totally take it if you just have the whole negative b plus or minus the square root over.
Oh, so
yeah.
So
So on the
yeah,
go ahead.
I was just gonna say the biggest thing is just simplifying the square root, like pulling everything you can out of it.
Yeah.
Yep.
And I would check simplifying that, like if you can reduce the square root anymore, like see if that number inside factors at all.
Yeah.
Because you might be able to like more easily reduce it, but
Okay.
Yeah. So on the exam, I would put in this answer so that you don't have that extra step where you could make a mistake. Right? Because if you simplify it wrong, you could have had the right answer before and then just did it wrong. So I would just do this form. Perfect. Okay. How would we start with this one?
Factor
Yeah.
the big denominator.
Perfect. And what do we get when we factor that?
X plus 3 and x plus 3.
Perfect. All right. So now what do we need to do?
Should we bring the 3 over to make it equal to 0?
We could bring the 3 over to make it equal to 0. Yeah.
Because this is similar to one we had on the last CBE, right? Where you,
Yeah, I think so.
where you times what it's missing. Okay.
Yeah. So we need to find a common denominator, right? You got to multiply by what it's missing. So what ones do we need to multiply?
So x plus 3 on the 13 over x plus 3.
Yep, and it's going to be x plus 3 over x plus 3, right? So we're not changing the value. Perfect.
And then we can leave 14 because it has everything, and then we would just times negative 3 by x plus 3.
Yep, this one is going to be by x plus 3, x plus 3. Perfect. So we're going to have 13 times x plus 3, subtract 14, subtract 3 times x plus 3, all over x plus 3 times x plus 3, right?
I think on that minus 3, you might want
Yeah.
Square root?
It needs both, right?
Yep, we need to multiply it by 2x plus.
Oh, yeah, sorry.
Yeah.
Yep,
X plus 3.
you are correct. Perfect. Now it's all equal to 0, right?
Right.
Since it's equal to 0, if we want to get rid of the denominator, we could multiply it across, right? What would happen? We multiplied the denominator on both sides to get rid of it.
It'd still be 0.
Yeah, so if we multiply both sides by the x plus 3 over x plus, or the x plus 3 times x plus 3, I don't have enough room. Then this would divide to 1, right?
Right.
And then this would be times x plus 3. And it's still equal to 0. So I'll have 13 is x plus 3, subtract 14, subtract 3, times x plus 3 equals 0. Perfect. Okay, now what do we need to do?
Just divide them into like 13x plus 39. We just times them all.
So we're distributing?
Yes.
Perfect.
Sorry.
Yep.
I'm not good with the good math.
No, you
No,
know
you're good.
I'm like,
Yeah,
we're gonna
yeah.
just
If you know what
rainbow
you're
it
doing,
over,
that's fine. Perfect. So we'll distribute this one, right? 13x plus 39. Subtract 14, subtract 3. And I'm going to do 3 times this, so it's faster because we know that's x, right? We know that this down here is x plus 3 times x plus 3. So we'll have subtract 3x squared, subtract 18x. I'm running out of room. Subtract 9 times negative 3, so that's 27. And that's all equal to 0. So now what do we need to do?
Combined like
terms.
Perfect. Combine like terms. Negative 3x squared. Check my math on this. Is this what you guys got?
Alright.
So
Yeah.
Yes, that's what I got.
that's what you got too? Perfect. Okay, sweet. So now, are we ready for our formula?
Yes.
We are? Oh, good to know.
Yep. So this is our A, right? This is our B.
Oh,
This is our C.
yes.
Perfect. So what is our formula going to be?
5 plus or minus square root negative 5 squared minus 4 times negative 3 times negative 2 over 2 times negative 3.
Perfect. So we can simplify. And what do we get under the square root when we simplify?
Oh,
25 minus or plus 12.
24. Wait,
Yeah,
25 minus 24, so 1.
Yes, just 1.
Yep, because we have negative 4 times negative 3 is negative 12, but then multiplied by negative 2 is 12 multiplied by negative 2 is negative 24. Perfect. So that's going to be equal.
Or negative 6.
Perfect. Sweet. Now, if we want to move our negative to the top, what are we going to have to do?
Do you have to move the negative to the top?
I think it
You
wants
can
some-
leave it for now. We can definitely keep simplifying this one, right?
Yeah.
So you could leave the negative for now, or we can move it out of the denominator. Either way works at this point.
Would you Just make everything on the top a negative, like times the whole top by a negative. Okay.
Mm-hmm. Yep. Yeah, I'm gonna do that just so that we're not dealing with the -6 down there. We could wait and we could do. Well, let's simplify it and then we'll take care of the negative. So we'll have x equals. If we simplify the top, what do we get?
Square root of 1 is 1, right?
Mm-hmm.
So it's just either 5 plus 1 or 5 minus 1.
Mm-hmm.
So x
So it's
equals 6 over -6 or 4 over -6.
Yep. So 5 plus 1. -6 over 6, which equals -1, and then this one becomes 4 over -6, -2/3. So if we write a solution set, sorry, this is kind of a mess. We'll check our answer. Perfect.
Got it.
How do we feel about those ones? Good?
That was
Okay,
good.
the last one.
It's doable.
We'll figure it out. It might take a few CBE tries, but
Yeah, we can come back and review problems too, like come up with some similar ones if we want at the end. We'll try to keep going with these, but we can absolutely come back and revisit things.
Sweet.
Okay, so for now, we're going to move on to solving linear inequalities. All right. Okay, we want to not overreact. It's just like solving a regular equation when we have something equal to something else and we're trying to solve for x. But we just have to remember that if at any point in our solving we're dividing or multiplying by a negative number, we need to flip our sign. Okay? All right. So we'll go ahead and start with this one. Okay, 4x minus 8 times the quantity 3x plus 2, and all of that is greater than or equal to -3. Okay, so again, overall we're just going to go forward in solving this as if that greater than or equal to was an equal sign. But we'll just have to remember that rule. If we need to divide or multiply by a negative number in our solving, we'll flip our sign. Okay, so with that, where do we want to start? What's our first step?
Distribute the -8.
Distribute the -8. I love it. Okay. And what do we get for that?
negative 24x
Beautiful.
minus 16.
Minus 16. Okay, and all of that is greater than or equal to -3. I'm going to go ahead and combine my like terms here. Just have negative 20x minus 16 equal to -3. Do we agree on that? Feel good?
Yep.
All right, what's our next step from here?
Add
Add
16.
to 16, yeah.
Beautiful.
13.
Okay,
And divide by -20.
And flip the sign.
Flip the sign.
beautiful. Nice job, guys. Okay, so now I'm going to say x is less than or equal to my -13 over 20.
No, 20.
Okay. All right, this is one way for us to write our answer. We can also write this in interval notation. Okay, do we remember interval notation, what that's referring to? Okay, how are we going to write this if it's in interval notation?
You do soft parenthesis, -infinity, comma, -13 over 20, and then a bracket.
Bracket. Okay, and why did we choose a bracket?
Because it's
It's equal to.
equal to or equal to.
Perfect. Yep, we're having less than or equal to. So our bracket is for inclusion. Okay, let's check ourselves. -infinity, soft parenthesis, to -13 over 20, bracket, or x is less than or equal to -13 over 20. Okay, nice job, guys.
Tapped in.
Okay. I'm gonna do this one too because I was sure. Okay. All right, so this is gonna keep going the same idea, but now we're adding in absolute values. Okay, do we remember how an absolute value changes things?
You get two solutions.
So yeah, basically plus or minus.
Beautiful. Okay. All right, so our steps for that, we're going to combine what we know about solving equations with absolute values and what we know about solving inequalities. First, we're going to need to get that absolute value all by itself. then set up those two scenarios with that plus or minus like we're talking about. Okay. Go ahead and get into this one here. Is there anything we need to do to isolate the value here?
Nope.
No. Okay. So when we're splitting this up into those two cases, what's it gonna look like?
3x minus 2 is less than or equal to 12, and 3x minus 2 is greater than or equal to negative 12.
Beautiful. Okay, and so we have a positive 12 and a negative 12. And a good thing to notice with that negative 12, we flipped our inequality too, right? So why did we do that?
Couldn't tell you.
Couldn't tell you? Okay. So this is a really good spot to stop and like logically check ourselves. If we got something greater than or equal to negative 12, say negative 10, right? Negative 10 is greater than negative 12. If we had, let me switch a color over here so that I can, say we have like negative 10 is greater than or equal to negative 12, right? So this is true, that's true. We're saying if we had something on this x side, negative 10. Okay, and we take the absolute value of both of those, right? We have that our 10 is less than or equal to 12, which matches our original inequality, right?
So it just wouldn't be true if we left it the other way.
Yep, so if we left it where we had it less than or equal to, we had that negative 10 is less than or equal to negative 12. Well, first off, that doesn't quite match, right? So even if, maybe instead of that, we'll say negative 14. Oh my gosh, it's not letting me write up in that corner. Negative 14 is less than or equal to negative 12. We took those absolute values. We have 14. It's greater than or equal to 12, but that does not match our original inequality. We have to keep track of this is our x side. So that does not match. Okay, so we want to make sure we flip that inequality when we're doing the negative option too. Okay, it's a good place to stop and double check. Does it make sense?
I'm a little confused with what you just did. You said 14 is not greater than or equal to
12.
Oh,
no, it is greater than or equal to 12, but does that match our original equation here? Mostly this inequality sign here.
No.
Okay. Yep. We want to make sure we're getting solutions that are less than or equal to 12. Okay. I don't know if this whole anti-example made sense, but does this whole double checking portion?
So when we make it negative, we flip the sign.
Yes. Okay. Oh, not ready for that yet. Go back to our red marker. Oh, that's the solution, but don't look at that, guys.
You can tap back it'll.
Yeah, now it's just making me draw on it. Okay, there we go. Okay, so we have our two cases set up. Let's start with just this 3x minus 2 is less than or equal to positive 12. We'll solve one and then we'll solve the other. Okay, somebody want to solve this for us?
So if you add 2,
Beautiful.
you get 10. Negative 10, sorry.
No.
Oh, we're over here.
Other one.
No, you.
So sorry.
You're okay. I see what you're going for there. Yeah.
I thought you were the underlying one was the one we were doing.
No, you're good. Here, go ahead and finish solving
Oh,
this one. If
okay,
we have
so-
3x is greater than or equal to negative 10.
So then you just divide by the 3 and you get negative 10 over 3.
Beautiful.
Yes. My bad. Sorry.
You're okay. You're all good. Yep, and since we divided by a positive this time, we're not messing with our inequality. Okay? All right, who wants to go through with this other one?
Yeah, add the 2.
Okay, add the 2. Beautiful.
Get 3x less than or equal to 14.
Okay,
And divide it by 3.
divided by 3.
You get x equal to, or less than or equal to 14 over 3.
Beautiful.
14 thirds.
Okay, so again, we have two options for how we might write our solution here, either with our inequalities or in interval notation. But let's combine these to make it one long inequality. This is going to be something where like a number, x is a number is less than or equal to, x is less than or equal to a number. Okay, so what would that look for this problem here?
Negative 10/3 is less than or equal to x
Mm-hmm.
less than or equal to 14/3.
Beautiful. Okay, so we'll either write it as like a long inequality like that, or an interval notation. So what would interval notation look like?
That's this parenthesis one, right?
Hard brackets.
Okay, we have a debate here. What are we checking for when we're looking for bracket versus?
Oh wait, I just was asking if it was the one where it was like in.
Oh,
Yes.
yes. So interval
But
is
they're
with
hard.
our brackets or with our parentheses.
Okay, but
Yeah.
they're hard because they're equal to.
Yes, beautiful. Okay.
Sorry.
No, you're good.
I wasn't trying to debate you.
Oh no, you're good. I was like, that's really fine. We're just gonna re-talk about why we're choosing which one. So yeah, we're just gonna do same numbers with our brackets because we are including. Okay, negative 10 over 3, 14 over 3. Okay, beautiful. They're kind of overlapping and hard to see, but that does match what we got. Okay, are we feeling okay about it?
Yep.
Okay, which is great because we have one more to practice with.
Let's go.
All right, what's our first step with this one?
Subtract 2 from both sides.
Beautiful. Yep, we need to isolate that absolute value. The absolute value of x plus 5 is greater than or equal to 0. Okay? Where are we going from here?
Subtract the 5.
Okay, before we do that though, we have these absolute values here we'd have to think about.
So we'll make two equations.
Yeah, so let's talk. If we're making
Yeah,
two
we can't make a
equations.
negative 0.
Yeah, right? That would be like if we're doing this. Which doesn't quite make sense. So let's pause for a second. Is there anything, any number, whose absolute value is less than 0?
No, it's infinity to infinity.
Yeah.
Or negative infinity to positive infinity.
Are we following all right?
That was a
There's
very- that was a
no
very
number I
simple
could
question
plug into
test.
this what I have right here. There's no value for x I could plug in, and where I would get something whose absolute value is less than 0. Okay.
Because absolute values are always positive, right?
Yep.
Okay.
Unless there's a negative outside of the absolute value.
Which, yep, unless there's something going on outside of that absolute value, which we already took care of when we did that. -2 from both sides on our first step.
Okay, so when an absolute value is equal to 0, it's infinity.
Yep, when we have that absolute value is greater than or equal to 0, our interval is going to be negative infinity to positive infinity. Okay, what if we got something like this? Oh, actually, wait. I want this to just be here. Okay, what if I had the absolute value of x plus 5 is less than 0?
No solution
No.
or undefined.
Yep, no solution. Yep. It's an empty set or it's just NA, no solution. Okay, awesome. All right. Yep, they're negative infinity to positive infinity. Okay. Functions.
Perfect. Okay, so we're gonna talk about functions, domains, and ranges of functions. So a function means that every input has exactly one output. That means it passes the vertical line test, right? So if we have an x, there's only one y for each x. It's written as f of x is the output function when the input is x. So like on our graph, we'll have x is the input, the x-axis, and then y will be the output. So if we have x equals 1, and say it's there, then we have our f of x. F of 1 equals 1. Does that make sense? Okay. The domain is all the x inputs that have an output. So if we have a graph that's going here, we ask ourselves, for what values of x is the graph present? So here it's infinity, negative infinity, positive infinity, because every x has a graph for it. The range is the same thing, but in the y direction. So x, y, and let's say it goes like this. What would our range be there?
Negative infinity to positive.
Because we're going to ask ourselves for what values of y does the line exist. Perfect. Okay. So if we have f of x is equal to x squared over 3 plus 2x, how would we find f of 4?
Plug 4 in.
Perfect. We'll plug 4 in for x. So f of 4, do 4 squared over plus 2 times 4. Perfect. And then what is that going to be if we simplify the numerator and then the denominator?
16 over 11.
Perfect. That's because this is 3 plus 8, right? Perfect. So we can't simplify that anymore, can we? Perfect. So f of 4 equals 16 over 11. All right, how would we do it for this one?
Same thing.
Same thing?
Yeah, plug in x plus h.
Perfect. Okay, so what is our equation going to be?
F of x plus h is equal to x plus h squared over 3 plus 2 times x plus h.
Perfect. And I believe on your CBE, this is an acceptable answer.
It
You
is.
do not need to distribute it any further.
Yes.
Yep. Perfect. Okay. So now we're going to talk about the domain and the range. So if we're finding the domain, what do we want to look at?
The
X-axis.
Yep, we want to look at our x-axis, and we're asking ourselves, along that axis, what?
What's the furthest point? Right?
Yeah, where does the line exist? So, what do we think?
Negative infinity.
6.
Yeah.
Perfect. And if we're putting in interval notation, what is our...
Soft bracket.
Mm-hmm.
Negative infinity. 6.
Perfect.
And just another soft bracket, right?
No, that one's a hard bracket because it's a
Oh,
filled-in
because it's
circle.
a definite end. Okay.
Mm-hmm. Yep, so we see that this is going infinitely in the negative direction, but it stops at 6. X equals 6.
Okay.
But since there's a point there, it is a bracket. Perfect. What about the range?
-1. Hard bracket -1. To positive infinity. Soft bracket.
Perfect. And why is that the answer?
The arrow is forever climbing, but -1 is the lowest point.
Perfect. Yep. Y equals -1 is the lowest. And then it goes up infinitely in the positive y direction. All right. If we're going to plot these points, how would we do that?
Just like find it on the x-axis. Go up 7. Put it on the
Yep.
other one.
Yeah. So in our coordinate, the first number is what?
4.
Yep. Is it our x or our y?
It's our x.
Perfect. And the second number
Is our y.
is our y. Perfect. So yeah, like you said, we'll go to 4 on the x-axis, and then go up to 7 on the y-axis. We'll have 1, 2, 3, 4, and 1, 2, 3, 4, 6, 7. And that is going to be 4, 7. Perfect. What about, I don't know, this is kind of hard to do with like, you guys, but same thing for the next one, right?
Yeah, just go 2 to the right and then
Perfect.
3 down.
Down 3, yep.
And then 1 to the left from the origin and 5 up.
Perfect.
And 4 on the left and 3 down. And then just 5 to the left and keep it on the line.
Perfect.
It's so hard to like vocalize that. I don't know why, but
Yeah.
I keep it on the line. They're all lines, but
Yeah.
on the main line, I don't know.
Yeah. Just say we go left 5 and we don't need to move up or down anyway, right? Because it's just 0. Perfect. Okay, well that's all we have. Is there anything you guys want to go over specifically, like more practice for anything?
You can pull up my bomb CBE.
Do you want to go over another one of those, like with the
Kind of.
fractions?
Okay,
I just am like confused. That's all though.
Yeah. Perfect. Did you have one?
Yeah, I just kind of made one up over here. It's not the prettiest solution, but at least I know that there is a solution, so we
Perfect.
can do that. Let me. Okay, we already have a blank slide. Beautiful. Okay, we're gonna do 3 over x minus 1 plus 10 over x squared plus x minus 2 equals positive 4. Okay. Were you here for this one?
I walked in about halfway through it, and this is one of the questions that I royally screwed up. So-
Okay, beautiful. I'm glad that we get to go over another one. Okay, what's our first step?
Find the least common denominator.
Yep, we're gonna find that least common denominator. Okay, we're gonna factor this right here, right? Okay,
I would pull an X out.
pull an x out.
Well, that was actually a dumb statement.
No, you're okay.
That's 2. Okay, -2, 1. So would it just be 1?
So you get x minus 1, x plus 2.
Beautiful. Yep, this is gonna be x minus 1, x plus 2. Okay.
And we have to distribute the x plus 2 to the 3.
Yep. So now we're trying to get that common denominator everywhere. So we're saying, okay, this 3, we need to multiply that by that x plus 2.
And then the 4 needs the x minus 1 and the x plus 2.
Beautiful. Yep. Okay. Okay, so now that I've given everything a common denominator, Maddie was showing this earlier, since eventually we're setting this equal to 0, and we would be able to multiply by that denominator to cancel it out, and it would just be 0 times whatever on the other side. At this point, we're just going to start working with our numerators, okay? Once we have that common denominator, we can kind of drop it and just focus on our numerator. Okay.
So your x plus 1, or your x minus 1 and x plus 2 on your answer side.
On this
are all
4.
gonna cancel each other out.
Okay, wait. Are we talking over here?
Yes.
Okay. Yes, they can absolutely cancel out. Oh, golly. Hello.
This is something I messed up. I didn't do any of it. So.
Okay, I don't know what this is doing here. I apparently am touching things. Okay. So we totally absolutely things could cancel out. It's just going to take us right back to where we were. So instead of canceling things out, we're going to start distributing.
I just erase the bottom and then just start distributing what's on the top.
Exactly. That's what I'm going to
Usually
talk
what I
about.
do.
Once we get the denominators all the same everywhere, we can stop worrying about our denominators. We can just focus on our numerator. Okay, so I'm just going to rewrite what we've got in the numerator so far. We got that 3 times x plus 2 plus 10 equals 4 times x minus 1 times x plus 2. Okay, and really quick, what is x minus 1 times x plus 2? Where did we get that from? Where did we get that x minus 1 times x plus 2?
From the denominator.
Yeah.
Yep, from back here. So with this 4, maybe I'm scared to go back to an eraser. It seems to be where I keep messing things up.
So they become a 4x squared plus 4x
Hello.
minus 8.
Sorry guys if you're... Sorry, I'm going to have you repeat that because I was absolutely preoccupied with
No,
the
you're
pen
good.
freaking out.
4x squared
4x squared
plus 4x
plus 4x.
minus 8.
Beautiful, yep. So that just came from distributing 4 to this x squared plus x minus 2. Okay, beautiful. Okay, what about this 3 times x plus 2?
3x plus 6.
Yep. Okay, I'm gonna go ahead and combine these like terms, that's 6 and 10 right there. Okay, what do we want to do from here?
I can move everything to one side.
Okay, which side do we want to, which things do we want to move?
We can move 3x plus 16 since there's less of it.
Okay,
To make it, and yeah.
okay, so we'll have 0 over here. What are we gonna have on that other side?
4x squared. Sorry, go ahead.
No, you're good.
1x,
Mm-hmm.
and then I don't know what that is.
Negative 24.
Yep, negative 24. Okay. All right. Okay, so now once we have it into this ax squared plus bx minus c form, we can either check and see if we can factor it, or we can jump into our quadratic formula.
Here's where I messed up. I didn't plug it into a quadratic.
Yeah, some of them you might be able to factor, but I'm gonna guess you're probably gonna be needing to use, I know on this one we're gonna have to use the quadratic formula. Because there's no way that this is gonna factor well for us. I don't want to try to factor this if I'm being honest, but you can always use the quadratic formula and it's good to get practice. Okay, so our quadratic formula is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
So you get negative 1 plus minus square root of 1
Mm-hmm.
minus 4 times 4 times negative 24
Beautiful. All
Over-
of this over
2 times 4.
Okay.
Gross.
Yeah.
So then you do negative 4 times 4, which is negative 8.
Negative 16
Oh, yeah.
times
Sorry.
negative 24,
It's been a long
which is
day. Which is 384.
Got one
You would do
positive or negative?
one minus 384 because of the 1 plus 384.
Okay, you got it, you got
I'm
it.
so sorry.
It's all right, you caught yourself, you're good.
And then 8 on the bottom.
Beautiful.
So 385. I'm guessing that doesn't. Well, you never know. Does it have a clean square root? But
It
we
does
can
not.
always. It does?
It does not,
Okay.
no, yeah. Yep, if we're coming, I'm gonna switch my color really quick. Okay, so when we're working inside of our square root, I wanna stop and check and factor it and see if we can simplify it, right?
Yes. So we can do. We can do like 5.
Mhm.
So 77 and 5.
Okay, 77 and 5, and then,
77 divides by 7 and 11, and those are both.
yep, all those
Can't
are
go
our
further.
prime numbers. Okay, beautiful, so we have our prime factorization, we have no pairs in there, no sets of 2. So
It's 385.
it's 385.
Okay.
It's just going to be the square root of 385. All right. Okay, so then to write our answer officially, we can't leave a plus or minus in there.
Yeah,
We
it
can
has to
take
be
care of
like
that.
negative 1 plus square root 385
Yep.
divided by 8.
Okay.
And then minus.
Yep, so officially our answers would be negative 1 plus the square root of 385 over 8 and negative 1 minus the square root of 385 over 8.
Okay. I just have one question.
Okay.
Way back when we did 4 times x minus 1 times x minus x plus 2.
Yeah.
Did you FOIL x minus 1 x plus 2 first and then apply the 4?
Yes.
Okay.
Yep.
I think that's just where I've been messing up this whole time. I've just
Okay.
been distributing the 4 to both of the parentheses and not getting the same numbers and then getting it wrong. So that would make sense.
Yep, so we want to be careful. If we are distributing that 4 to both sets of the parentheses, what we're actually doing is 4 times 4 times x minus 1 times x plus 2.
Okay.
Because you'd be distributing a 4 to both of those, which we don't want to do. We only want the 1 4, right?
So just FOIL them first and then distribute in the 4.
Yep, especially because you're foiling. It's probably it should most likely just equal whatever that biggest denominator that we started with factoring was.
Okay. Because I wasn't getting like an x squared in there, and I was like, I don't know how I'm supposed to.
Yeah.
Okay, that makes a lot more sense.
Okay, beautiful. I love to hear that. Okay, so yeah, what we really did was this, which gave us that 4x squared plus 4x minus 8.
Okay.
Okay, are we feeling better about this kind of problems?
I am.
I can remember all the steps that I need to do. Like, oh yeah, I need, now that I have this, I need to do this.
Yeah, practice definitely helps it to be more familiar and like just get a little bit more comfortable.
Yes.
Alrighty, I think that we are just about out of time. Any last questions that you guys have?
So the one on the CBE that is like multiple choice, and it's like, is this 0 or do you know what? Someone, you know what?
Yeah, you're talking about the one like, what's the solution set for this equation? And it'll give you like negative infinity to positive infinity, 1 to positive infinity, like
But it's
just
like
negative
random.
1.
Is that mainly, well, now that I understand the zeros, I guess that's the only question I had.
Okay.
That made no sense. I'm
No,
so
you're okay.
sorry.
You're okay.
I'm just thinking through it out loud, I guess.
That's totally okay. And if you want, like in the tutoring center, and I'm sure your recitation leaders can too, we can pull up your old CBEs.
I am.
And be able to look over them with you.
Okay.
Like absolutely, please, if you have like more specific questions about a problem you keep getting wrong, come talk to us about it in the tutoring center or with our recitation leader. And absolutely help you with it.
I don't feel like the refrigerator's warm.
All right.
I appreciate it.
Okay, thanks so much for coming, guys. Again, this will be posted on YouTube at some point on our MLab channel.
It was toasty.
Yeah, it's warm.
Okay.